In this video, I will code Lagrange's interpolation method. I have pulled up a page from Google which supplies us with a formula, and it's something like this. Just focus on these two lines. Well, f of x equal to x minus x1 into x minus x2 into x minus x3 and so on and so forth, excluding x minus x0 for the first term. And for the, let's say there are four terms, so for the fourth term, excluding x minus x4. So the ith term, for the ith term, the numerator x minus xi is ignored, right? And for the denominator, it's xi minus x1 into xi minus x2 and so on and so forth, excluding xi minus xi. Like, it will be zero, right? Anything divided by zero is infinity, so we leave out that term. So this is our formula, and get to the code here. Well, just hold on for a second because I need an example as well. Let's open the book, page 78. Okay. Do I have an example here? um, let's see. I don't see an example, but there has to be some. Oh, this is an example, so let's try with this one only, right? So x's are this and y are this. Yeah, let's try with this one. But what do we have to find? Okay, find f of 0.3. Okay, fine, this is an example. We'll use this one only. And okay, let's begin. Hash include stdio.h, then conio.h, then int main, return 0. I need an x array, so let's set the type as float, and 10 comma y, again 10. Now time for inputs, so void void input here. Printf, enter the number of terms, so I need an n also. Scanf %d and %n. Okay, then I need I and j, so for I equal to 0, I is less than n, I plus plus. I don't need j actually, but let's print something here. Printf enter the x terms one by one. Scanf %d and percent of x array I. Well, it's not percent, it's %f. I keep making this mistake. Now let's copy paste this thing for the y terms. Let's replace x with y, and here also x with y. So our input is done. Now just hold on, let me see if sound is getting recorded or not. Yeah, record audio. Okay. Now it's time to make the numerator, I mean the numerator, like this part we have to make. So float numerator, then int I means the ith term, like I'm showing you here. Like for I equal to 0, we will miss out x minus 0 x0, right? And if ith term is 0, we'll miss out x minus x0. So I need the ith term here, that's why int I, and then float mul equal to sorry, let's make it 1. Then for uh int I also need int let's say j. Then for j equal to 0, g is less than n, g plus plus. Then we have to check if j is not equal to I. If j is not equal to I, then we'll do something, and that something is mul into equal to, means mul equal to mul into something, and that something is x minus xi, x minus xj. Okay, so I need that x also. Sorry, float x minus, oh, I can't make it x because we're an array with the name x, right? So let's make it a minus x of j. Okay, I think this should be it. G is not equal to I, then mul equal to mul into a minus x of j. Okay, now let's return it. Return mul. Okay, now for the denominator part, I more or less is a copy paste of this with a minor modification. Instead of num, let's make it denominator. Denominator I and a. Okay, and this. Okay, fine. If g is not equal to I, okay, then mul equal to mul into, I don't need a this time, this I don't need, because if you can see it's x0 minus x1, x0 minus x2, so the ith term is more than enough. So it will be x of I minus x of j if g is not equal to I. So this is done also. Now we have to find the answer. Float answer, I need the x term here. I mean, what I mean by x is this x, this x, and this x, and that x means I have to find it for some x, right? So that I have to enter in this function as a parameter. Okay, and how should I proceed? 1 2 3 4 5, if there are 5 terms, I have to run this program 1 2 3 4 5 times. Okay, so let's declare I first. For I equal to 0, I is less than n, I plus plus. Then I also need mul again. Mul means multiplication, if you can't understand, so yeah, mul means multiplication. Do I need mul here? Not, it's not multiplication, addition this time. So add equal to 0, add plus equal to something, and that something is something into something. right? As you can see, it's something, sorry, something into something, something into something, and that second something is our y. So it's y of I, and that first something is numerator by denominator. So numerator by denominator, numerator by denominator. And for the numerator, it's for the numerator is just I, it doesn't matter. Numerator it's I comma a. Numerator it's, yeah, I comma a. Okay, so this should be it. Let's return this, return add. Now let's call the functions, input, then printf, answer is something, and that's answer of a. But before that, enter the x to find so let's input this float a, then scanf %f comma ampersand a. So let's see, we have got an error. I missed a semicolon somewhere, yeah, here, and then again I missed semicolon here, and then again I missed semicolon here, again, okay. Number of terms, how many terms do I have? 1 2 3 4 5, so 5 terms. So 5 terms, and the x terms are 0 1 3 4 7, and the y terms are 1 3 49 129 and 813. Enter the term to find, it's 1, it's 0.3. As you can see here, it's 0.3. So I'm getting the answer 1.83100, and the answer which they are giving is 1.83100. Yeah, so I'm lucky enough, I guess, because in one go I this program correctly. This is all for this video, I guess, because the answer is correct, and yeah, it's getting recorded also. This is one video which I had uploaded. It's on a basic pattern in C. If you want to watch this video, it's a nice video. Let's pause this music, sorry, sound. It's solving this pattern like this. It's a bit more complicated, it's not so easy pattern. It's more than it's easy actually, but if you're like, if you're starting out or something like that, you can take this as an example. Anyways, let's show you the pattern first. Yeah, this is the pattern. So if you like this video, do hit like and do subscribe for more videos like this. Thank you and have a great day.